Hello everyone! On a previous episode of Tinkering with Terrius, we built this little voltage regulator board, and this voltage regulator is going to be used to take 1.5 volts from a D-cell battery and turn it into 5 volts for a bunch of LEDs that are connected to a PIR sensor. So the next part of this that I needed to build was the transistor board. So this transistor board is to control the current for the LEDs. So this little transistor board is made up of just 2 transistors and 2 resistors. One of these resistors is a 40,000 ohm resistor, the other is a 1,000 ohm resistor. There's 2 connections here that aren't connected. Those bare wires are actually for a photoresistor. A photoresistor goes across these and creates a voltage divider with the 40K resistor. And using this voltage divider, it sets what the threshold for the level of light in the room is before it will activate the PIR sensor and allow the lights to turn on and off. So it's a pretty simple little circuit, not too much fancy stuff going on. It is kind of a mess on the bottom because of all of the connections that have to cross each other. I want to hook this up to the voltage regulator here, and I want to see if this is going to work. I have some LEDs on a breadboard so that we can test and make sure that this has enough power for it. Now, I did mess up on this when I was building it. I put the pins on the top of the board. I should have put them on the bottom of the board so that it would easily socket into this connector here on this. Unfortunately, in order to socket that in, I would have to put it like this, and then I can't get to the part where the PIR goes or any of the outputs. So instead, we'll just have to use some jumper wires. We also have a AA battery to stand in for the D-cell. PIR sensor itself, and the LED board. And to stand in for the photoresistor, I'm going to be using a 1 megohm resistor, and that's just simply so that it always remains active and it doesn't shut the circuit down, because for testing purposes it randomly shutting off is very frustrating. We're also going to measure the current draw, because that's fairly important as well. Everything should work now. Okay, so the LED is illuminated, which means that the PIR turned on. So you can see that right now it's drawing about 45 milliamps. So the LEDs here are 4 LEDs in parallel, and each of those parallel LEDs has an LED in series with it. So this 45 milliamps is definitely well divided. That means they're each receiving about 11 milliamps, which isn't too terribly high. It is sitting right on the edge of the maximum output of the voltage regulator, so because of that, I'm actually going to add in a resistor on the output when I build this on the smaller board. Thinking about 100 ohm resistor should work. Should limit it a decent amount, but this one's working perfectly. So now I'll cut to a time lapse of me building the other circuit. Okay, so this is the finalized circuit here. It's quite a bit different than the previous one. It's much smaller. This is our previous iteration, and it's a fraction of the physical size. It's only 6 wide by about 17 long pins. I do plan on sticking it to the side of the battery compartment at some point. Probably going to use hot glue for that, but of course we have to test it first, make sure it works. This has some cable coming off of it, some phone cord, and that's being used to attach to the components. On the final version there'll actually be a female connector that will go here rather than just a bunch of jumpers. Same with this. This is the photoresistor, which, just like the other test, we're going to be substituting in the 1 megohm resistor. So you can see we're getting 36 milliamps. Now the 100 ohm resistor that I had chosen did not work for this. I had to add a 10 ohm resistor in parallel with it, bringing it down to 10 ohms, and that was because at 100 ohms this was only putting out 10 milliamps. And 10 milliamps was barely enough to light these LEDs. Now if you just use it open circuit, that's also an option without the resistor in there, and that was getting us 45 milliamps, which isn't too terrible. It isn't too high. The LEDs could certainly withstand that, but my goal was to essentially get it the brightest I can for the least amount of power draw so that this D-cell battery lasts a ridiculously long time. And that's what I've achieved here. I'm just waving my hand in front of the PIR to keep it lit here, but you can see that's exactly what our goal was. It's almost dead on what I wanted. Everything's working just fine. Now unfortunately, I don't think my camera will be able to pick up the red light from the LEDs if I try and shoot with it. I'll try to take some long exposure pictures once I have them set up in here, and I'll put those at the end of the video here. So I hope you enjoyed this episode of Tinkering with Terrius. If you did enjoy this episode, then be sure to give it a big thumbs up. If you didn't enjoy it, then of course you can give it a dislike. If you haven't already, then be sure to subscribe to my channel if you want to see more content like this. And if you want to make sure that you know when a video of mine is posted, then hit the little bell notification icon. If you have any friends that you think might enjoy this video or might be interested in the PIR series here, then be sure to give this video a share. If you have any questions or comments, then definitely leave them in the section below, or you can email them to me, or you can tweet them to me. If you have suggestions for future episodes as well, send those over. Thank you for watching. I hope you have a wonderful day.